Hi everyone, this is Gad, and as usual, here we are doing the learning to become a computer scientists. So, actually, I'm very happy. I bought new headphones. So I'm ready now to start, and I think this session will be a little bit long. Yeah. Excuse me. So, as we said before, this is my channel. If you like to do, if you like to share it with your friends, that will be awesome. And there's something I want to say. I do not do any. Actually, I'm not doing anything about the videos that I'm recording. That means I do not do editing of this video. So if there is anything you want to tell me about it, just you can do it in the replies in the comments below the video. So as we said before, I am going to finish these today. This is why it's going to be long. And as I mentioned before, the last video ended here. Uh, that was the video of knowledge, and I did this two exercises, and actually I really recommend doing some doing this doing this course. Actually, it's really the question have escalated very fast actually, and I'm happy to see this kind of courses that give a really good high education, because before the courses are really very like very how can I say it, poorly questions. There is a very poor question inside it. You don't you don't have to think about answers, but this is the first two exercises, and I do think for being the two first and for beginners, that's really uh, a very good establishment of knowledge. So great. I do consider you take this course really, and as we said before, I will. Yeah, I'm going to do this. Where is it? Yeah, GitHub. And as I said before, we are following this GitHub page, this GitHub course, this GitHub curriculum actually, and as I read, and as the people who recommend this, these are preparation. Okay, so you don't have to be very fluent in it, but I'm taking it seriously. Um, but actually, we you don't have to, because the real deal is here. You know, when you are starting, this is to understand what we are coming to. So closing this. So preparing everything. This is my Google Translator. is here. Everything. I do like also to keep page of the page of the course, and my notebook for taking notes is right here. Stilos, my stilos. Yeah, stilos is in French. I did just GitHub. I just did this to see. That's it. I hope everyone is ready. Refreshing to see this annoying message. What is it? So refreshing, very good. We have internet, and I hope my screen do not cut off. So hope you're going to do some good stuff with me today. And let's go. Let's dig in it. Let's dig in.
We've described a recipe. We said it's a sequence of mechanical steps. It's going to capture the sequence of things I want to do in order to compute something. But now I want to get it inside the computer. I don't want to just give it to my friend and have him do all the work for me. So the next question is, how do I capture a recipe inside a mechanical process? Go back to my square root example. I'd like to get a machine that's going to compute square roots for me. Historically, there were two choices here. The first one was to use what was called a fixed program computer. And this would be a computer designed specifically to calculate a particular computation. You've actually seen them. Actually, you may be too young to have seen them, but people my age have seen them. Handheld calculators were a fixed program computer. They did addition, subtraction, multiplication, a simple set of arithmetic operations. That's all they could do. If you wanted it to search the web, good luck. Wasn't going to happen. Very famous historical example was Alan Turing's bomb. This was a machine designed during World War II to break German codes for the Enigma machine, and it was designed specifically for that process. It was also built out of devices you don't see anymore, like vacuum tubes and relays. And you can imagine the challenge of building such a machine, but it was designed to be a fixed program computer. That'd be boring if that's all we could do. I don't want to have to carry around a computer for square root and a computer for cube root and a computer for quadratic root. You get the idea. The alternative is what's called a stored program computer, and that's what you're used to seeing. Difference with the stored program computer is that you can load into it that description, that sequence of instructions, that recipe. And then inside that computer, there's going to be a set of parts that are going to do those instructions when I ask them to. And in particular, there's going to be a special program inside the computer, typically called an interpreter, which when you start it up is going to walk through each of those sequence of instructions in turn, doing the computation I want. And the advantage of a stored program computer is I can load in a different program and have it do the same thing. In essence, that stored program computer is emulating or imitating a fixed program computer for each program that I load in. It gives me an infinite range of things that I'm going to be able to do. So what I want to now think about is, how do I take a description of a process in those mechanical steps and write it in such a way that I can load it into the computer and the computer can do the work for me. Before I do that, I need to think about what's inside the machine. So we're going to take just a second to open up the hood and look inside a typical computer. Basic machine architecture of a computer has some simple pieces. It's obviously got some memory, places in which I'm going to store things. Now up here in this memory it could be
So guys, maybe I will pause a little bit for taking notes, for example. Excuse me, I'm just trying to do it properly. So for you, I think like this. Yeah. Okay, let's go.
data.
I'm taking notes also if he's speaking anything very serious, but I don't think there's a lot of stuff here.
But it also could be a sequence of instructions that are my program, that mechanical set of steps. I haven't said exactly what they look like, but you got a sense of them from what I did in that square root example. I'm also going to have a way to load things into the machine and print things out of the machine, input and output. We'll come back to those later on. Inside the heart of the machine, there are two elements. The first is often called an ALU, an arithmetic logic unit. And what this unit does is it takes information from memory, reads it in, often two pieces of information if I'm going to do an operation that takes two inputs. It's going to do a primitive operation, could be addition, could be subtraction, could be testing to see if something is true or false, and then typically it's going to store stuff back up into memory. To make that happen, we need one more piece, and that's the control unit. And that's going to keep track of what specific operation I want to do in that ALU at each point in time. And inside the control unit, there's an important thing called a program counter. So very simply, when I load a program into the machine, in a second we'll get into how to do that, but I load a program into the machine. It's a sequence of instructions up here, and the program counter points to the location of the first instruction. And when I ask the machine to execute, That program counter reads that first instruction. It's going to cause an operation to take place, and it's then going to add 1 to the program counter, which is going to take it to the next instruction in the sequence, just as we saw in the square root example. That's going to do another operation, typically doing some arithmetic operation, moving things back into memory, and it's going to increase the program counter. Eventually, we're going to get to a test, and that test is going to say whether something is true or false. And based on that, we're going to change the program counter to go back up, for example, to the beginning of the code. But that's in essence what happens inside a modern machine. Control unit tells me where I am in a sequence of instructions. I've read into the machine, that stored program. That causes a
So it's easy. I don't. Yeah, I think I enjoy this. Yeah.
simple loop inside the machine
Nice.
of operations. When I get to a test, it's going to potentially change the program counter. And when I get to something that says stop, it will, and it'll print something out on the machine. That's the heart of a machine. It's all there is inside a computer. All right, there's a lot of stuff inside there, but that's basically what the machine's going to do. And our goal is now to figure out how do we write that sequence of instructions so that the computer can do the things I want it to. To summarize, a stored program computer then is going to be that sequence of instructions. It's going to be built out of simple arithmetic and logic instructions. It's going to be built out of simple tests, and it's going to allow us to move data around. And associated with that is going to be this special program called the interpreter that's going to execute each of those sequences of instructions in order, changing things with the flow of control when a test says, I want to go somewhere else. And then finally, when I'm done, print out the answer. That sounds great. So what are the basic primitives? Most machines will come, as I said, with simple arithmetic and logic operations. But in fact, you can go even simpler than that. And if you go back to that gentleman I mentioned earlier, Alan Turing, one of the greatest computer scientists in the history of the world, Turing showed that you can compute anything with just 6 primitives. In fact, there's something called a Turing machine, an example of which is shown in that little image on the slide. A Turing machine is an infinite tape with a set of squares on it. In that, each square there's a symbol, could just be a 0 or a 1. And what Turing showed is if you have 6 operations, and those are move left, move right, scan, read, write, do nothing, with just those 6 primitives, you can compute anything that's computable. You're now panicking and looking to find a different class, because if what you had to do was program a computer by saying move left, move right, read, write, scan, stop, you don't want to program. Fortunately, modern programming languages come with a more convenient set of primitives. But the fundamental idea is that with a simple set of primitives, you should be able to compute anything. Equally importantly, you don't want to just write everything in terms of addition, subtraction, logical tests. What you want to do is write descriptions, like that square root program that we talked about earlier, and then abstract them. And I'm going to highlight that word because abstract is going to be really important. You want to treat...
I am finding, yeah, like, look, guys, I do find this this is weird, like, I don't know, I'm a little bit funky, me too, I don't know.
that square root as if the manufacturer had built a little primitive and installed it in your machine. You want to be able to use it as if it was something that came with the machine. And that's what the power of computational thinking is going to give us. One last thing about computation. Let's go back to that Turing machine idea. I said you could compute anything if you just had those 6 moves. There's some nuances to this. A more sophisticated computer scientist could debate some of those details. But there's a fundamental property which says anything that's computable in one programming language is in fact computable in any other programming language. Wow. That's amazing.
That's lame.
Well, you get heated debates between people about whether Python or C or Fortran or Lisp is the best computer programming language. They're all the same. Okay, slight misstatement. Some are going to be easier. Let me rephrase that. In some languages, it's going to be easier to do some kinds of things than others. In MATLAB, it's easier to manipulate matrices. In C, it's easier to deal with web programming. But But nonetheless, anything you can compute in one language, you can compute in any other language. And this is a property called Turing complete. It's one of the fundamentals of computer science.
Well, actually, guys, I didn't take a lot of notes, so
We've
yeah, we'll jump ahead. We'll jump ahead for the next video. There is a question. I'm going to jump now to the videos, and in the end, I will pause a little bit, redo all the test questions. Note that I'm not going to have verified the certificate. I'm not aiming for certificate, so yeah.
So now we've got the idea.
I don't care if I do the exams, the test or not, but I do find it's very helpful to do it. Actually, we are going to have a lot of tests in this journey. Yeah.
Of creating a recipe as a generic idea. We know a little bit about what's inside the machine. What we need to do is put those two things together. We want to now go from a description of a process to a specific set of statements that we can store in the machine so that that interpreter, that evaluator, can then run those operations to use the primitives inside the machine to do the work for us. As we've said, programming language is going to provide us with a set of primitive operations. And the next step is to start talking about how do we put them together. To do that, we use something that we call an expression. And the expressions in a language are simply more complex but legal combinations of primitives that the programming language will recognize. And we're going to start building those up. So you're finally getting to the stage, after all of this high-level discussion, of getting to the place where we're going to begin to get the computer to do something. One of the things we're going to talk about, though, is that any legal expression in a programming language, any computation, has associated with it a value. That value is the meaning of the expression, and that's going to be important. In part because if we know we want to get to a particular computation, we want to understand how do we get to that value and how do we back out of that the sequence of steps, the expressions that are going to compute it for us. So let's look at how we put this together. Every programming language can be thought of as consisting of a set of primitives, a means of combination, a way of putting those primitives together to create new expressions, and a means of abstraction, a way of taking some complex expression and treating it as it's a primitive. To talk about this in a programming language, I'm going to give you an analogy to a natural language like English. In English, what are the primitive constructs? They're words, lots of them, some of them more common than others. In a programming language, we also have primitive constructs. These are the atoms on which we're going to build things. And in a programming language, those are typically numbers, strings, or just sequences of characters, and simple operations, the things that were provided to us by the manufacturer. Addition, subtraction, comparison.
Yeah.
Given those primitives, we want to put them together. When we put them together, we have to think about two different parts. This is taking you back to an English class, because we have both the syntax and the semantics. The syntax is that parsing of a sentence.
I like this. I like this. I like this.
To know, is this a legal sentence or not? And some combinations of expressions are legal, some are not. For example, in English, cat, dog, boy is not syntactically valid. It does not make sense. There's no verb in there. On the other hand, cat hugs boy is syntactically valid. It is a noun, a verb, a noun. That's something that makes sense. The same thing's going to happen in programming languages. Some combinations of primitives are not legal. They're not syntactically valid. For example, this expression.
I like this
here,
definition.
the first part, we're going to come to this in a second, is a string. It's a sequence of characters enclosed in double quotes, followed by a number. It's not a legal expression.
My chair is
On the other hand,
hurting
as
my
we'll see in a
back.
second, this is a syntactically valid expression. It consists of a number, an operator, and a number. So we're going to talk about how do we put together legal expressions. What is the syntax of those, both in terms of simple combinations like this and how we do it when we get to more complex aspects of the language. Associated with every expression that is syntactically valid is potentially a meaning, the semantics. What does this expression evaluate to? And here we're going to separate out both static semantics and full semantics. Static semantics tells us which syntactically valid strings actually have a meaning. In English, in bad English, the sentence, "I are hungry," is not actually meaningful. It's syntactically valid, meaning it's put together properly. It's, in this case, a pronoun, a verb, and then an adjective. Perfectly legal combination, but semantically it doesn't make sense. Same thing happens in a programming language. The first expression, 3.2 times 5, is syntactically valid. The second one, 3 plus the string high, is syntactically valid. It is a primitive, an operator, and a primitive. But semantically it doesn't make sense. I can't add a number and a string together. So we have to distinguish things that are not statically semantically valid, because they're not going to be expressions we want to try and assign a meaning to. Once we have both syntactically correct and static semantically correct expressions, we want to then know what's the meaning associated with them, and we're going to start building this up. Semantics then is the meaning associated with that syntactically correct string of symbols with no semantic errors. Even here there can be some wonderful nuances. In English, we can have a sentence that's both statically semantically correct and syntactically correct, but can have multiple meanings. Flying planes can be dangerous. Does that mean if I'm flying it, it's dangerous? Does it mean if they come out of the air and crash on you, they're dangerous? There are multiple interpretations to it. Or from an old joke, this reading lamp hasn't uttered a word since I bought it. Obviously playing on the word reading lamp in a different way. Different meanings associated with it. In a programming language, there's both good news and bad news. The good news is any syntactically correct and static semantically correct expression in a programming language will only have one meaning. But the challenge is it might not be the meaning you intended. And that's where...
So I'm just going to take some notes. I think it's nice to take these notes here.
Bugs are going to show up, and we're going to come to that as we go through the term. But these pieces now are how we're going to talk about the language.
Some notes.
What's the syntax of putting things together, and what's the semantics, the meanings associated with them. With those three things in mind, you can ask what could go wrong. And these are also things we're going to see in the course. First of all, I could have a syntactic error. I've not written down a legal expression. These are common and easily caught, and in fact, most good programming languages or the environments that interpret them will catch those directly. As you'll see as we go along, and I'm sure I'm going to make some mistakes as I do some work here, Python will catch those right away, so you won't try and do anything with them. Once you got something that's syntactically correct, what about static semantic errors? Things where things are in the right order, but they don't make sense. Some languages are very strict about catching these. They'll actually check before you ever run a sequence of operations to make sure there are no static semantic errors. Other languages, and Python is one of them, will do it on the fly. As you're going through a sequence of instructions, when it comes to one that is not statically semantically correct, it will stop. That's good news, but it can lead to some unpredictable behavior, and we're going to see that as we go along. The bigger problem is one where there are no semantic errors, but you get a different meaning than what you actually intended. These are the bugs that are challenging and are going to be difficult to find, but you need to find. And what are some of the consequences? The program could crash, simply stop running. Even worse, the program could run forever or until you get really tired and stop the machine because it's not coming back with an answer. And even worse yet, the program gives you an answer, but it's different than what you had expected, and you're going to use that to now do incorrect conclusions based on that error in computation. So what we're going to do now is start talking about Python, and our goal is to learn the syntax and the semantics of this particular programming language, and then to use that to learn how we can translate our recipes for solving a problem into a form that can go into the computer so it can run through that very mechanical sequence of steps to compute the things that we want to do. And finally, as we do all of this, we're going to start seeing patterns of computation. We're going to build up computational modes of thought, different styles of solving problems, because those styles are going to be common and can be easily reused when we see a new problem that fits into the same category.
All right then. next, where this one. So jumping ahead for videos. Yeah, go.
Now that we have the idea that we want to put together expressions by putting together primitives in legal ways, we can take up that idea of how to use that to start capturing recipes, start capturing algorithms. So let's talk about a Python program. Python being the language we're going to use in this class to do programming. And a program, just as we saw with the recipe, is going to be a sequence of definitions and commands. Definitions, as we'll see a little bit later on, are ways of either assigning names to values or, more importantly, creating procedures that we're going to treat as if they're primitives. Those we refer to as being evaluated. Commands are simpler expressions that we can execute directly within Python. And we do that in something called a shell. And in a moment, I'm going to use a shell. A shell is simply a window into which I can type expressions. They get passed into the Python interpreter. It follows the set of instructions to figure out what's the semantics, what's the meaning associated with that expression, and then it prints out the result. Commands are statements that instruct the interpreter to do something.
Searching in my
So the commands could be simply
something.
do this arithmetic operation, or commands could be apply a primitive that I created to do some work for us. The last piece, and we're going to see both of these as we go through the course, is that we can either type things directly into the shell. That's a window that the interpreter is listening to. That's something where we type something in and the machine does something with us. Or we can store it in a file that gets read into the shell when we're ready to use it, but otherwise can be saved away. To start with, we're just going to type directly into the shell, but we'll see examples of files in a little bit. Okay, we're almost ready to start programming. We know the pieces we need. Let's start with what are the fundamental primitives that represent data. Those we call objects. And programs manipulate data objects in order to get out parts of those objects or to do something with those objects. Every object has a type associated with it that tells us what kind of thing it is. And more importantly, that type is really important, that type tells programs whether they can act on it or not. If a program is expecting a number and I give it a string, it's not going to try and do something with it. So the type of the object is really valuable. Finally, objects come either as scalars, which says they can't be subdivided, or if they're scalars, obviously non-scalars, which are things that have internal structure into which we can pull out parts. Let's start with the simplest version of these. Scalar objects in Python. There are very few of them. We have ints.
I'm going to
These are
open my,
integers.
text
Standard
editor.
numbers that you recognize, 5, 17, 27, -6. We have floats. These are real numbers, things with numbers after the decimal point, 3.27, 3.14159, my favorite. You have something called a bool, short for Boolean, and that represents true or false. Those are going to be important when we get to tests, because we want to know if a test is true, do something. If it's not, do something else. There's one weird one. It's called none type. It's a very special one. It has only one value, which is none. We're going to see why that's important later on, but just to be careful, none type is a scalar object. Those are...
So guys, actually I want to say, maybe I do learn more when I explain what did I learn for myself. So technically I'm explaining this for you, so I'm speaking out loud now. So it's easy. Integer, floats, Boolean, and the none. That's we don't know what is it. No. So these I'm not going to speak about this. Let's just stick with these first three words: integers, float, Boolean, integer, float, Boolean. Well, actually, we are going to hear this a lot. So integer is always a number with no decimal. So it's like from 1 to infinity, I think. And 0, maybe. Yeah, 0 is an integer. And float is when we have decimal. So this is it. And Boolean, yes, no, question. So yeah, I am weird to learn like this, but I'm sorry. I'm just sharing my method. So continuing, go.
4 fundamental scalars. There are only a couple of more which we'll get to a little later on. Once I have knowledge of those different types, I can also find out the type of a number.
So let's do what he's talking about. I think he is going to explain this, but it's obvious. So I prepare my text editor. So if you are wait, don't save. Okay, don't save. What is this? What is this? So if you are using this type of text editor or any text editor, there is something you should do. So I'm going to do file, a new file, and we have a text editor. You know, like I'm sorry. Whoa. Yeah, that was very weird. So it's like text editor in Windows, small text editor, but it's we understand more than one language. So here I am going to do Ctrl Shift S or save as Ctrl Shift S. So this is the I think my actually I'm going to do this here just to make sure I am on my desktop. I don't like to show out my desktop. New and folder. New folder here. I'm going to name the new folder YouTube. What was that? Learning. No, learning. I did spelled learning wrong. Nice, dude. So learning, yeah. So we are here on my desktop learning. So I am going to save it here and watch what I am going to say. The file name, I will call it first, for example. First, dude, please. .by. So this is the extension of the file, so it will understand directly, and when I hit save, it will understand directly it's a Python. Look, it's the sign of Python, so it did understand it's a Python code, you know. So this is the preparation for me, and let's see the video and continuing.
Object by using a built-in procedure called type. And I want to show you some examples. So I'm going to go over to my little machine over here, and I'm going to...
Actually, he is working on Spider or Anaconda or something, like something, I don't know, where is it? He did explain it in the beginning, so jumping on my first... so it's like this, it's here, downloading Python and getting motivated, that's it. There is no much things to do. Actually I do recommend to do Atom. Atom is very simple environment that don't take lots of stuff, and VS Code is what I'm using. Actually I do recommend VS Code also.
Skip down. I'm now talking to a shell. And you'll notice it's got a little prompt that says in, saying what's the input you want to give. The fact it's got 30 on the machine is because I was doing some other work earlier. So this is going to be the 30th expression typed in. And I'm simply going to type in a number. And the output is the number itself. Well, duh, you say. But it's actually important because what the machine did was it read in that sequence of characters, understood that it was a number, and the value associated with the number is simply the number. And in fact, I can check it because I can say, what's the type of 3.5? Notice the open and closed parentheses around it, and it says it's a float. And I can have integers, and if I say, what's the type of that? It's going to give me back an int. Simple things. Okay. Again, just to recap, what this says is here's what I'm going to type in to this Python shell, and here's what shows up after I hit enter, after I hit enter, as you just saw. And in and out are simply going to identify what I typed in the output, that you sequence of characters. Understood that it was a number,
I will try
and the
what
value
is
associated with the
saved.
number is simply the number. And in fact, I can check it because I can say, what's the type of 3.5? Notice the open and close parentheses around it, and it says it's a float. And I can have integers, and if I say, what's the type of that? It's going to give me back an int. Simple things.
Okay, let's do this type. Let's write type. So type. I'm sorry. Yeah, type 12. Yeah, and let's do run. What is this? Well, I have to do save. So save, run. Nothing happened. Do think I did save. Yeah, save. So maybe we're not seeing it. Run. Yeah, I don't know. So type. Sorry. What? Let's do this. Type object. The object type name is detect dictionary. And you type. Well, I don't know. I don't know why it's not working. Well, I type. Yeah, type. Did I spell it wrong? No. So type of maybe doing this as no. Okay, so this is weird. Let's do the same. 3.2. Run. I don't know why it's giving. It doesn't give me the same. Yeah, never mind. That's nonsense. Yeah.
Type of 3.5. Notice the open and close parentheses around it, and it says it's a float. And I can have int.
Yeah, I don't know. So yeah, I did search that on YouTube. Apparently I have to do this. So I have no clue what is it, but why? I don't know why. So I have to print open parentheses type open parentheses, and you write a number and Control S, and it's a integer. We have an integer here. So this is a command in Python. I did know it, but I don't think it will do it. Yeah, it's like what he's doing here, I think. Yeah, wherever. Continuing.
And if I say, what's the type of that? It's going to give me back an int. Simple things. Okay. Again, just to recap, what this says is here's what I'm going to type in to this Python shell, and here's what shows up after I hit enter, after I hit enter, as you just saw. And in and out are simply going to identify what I typed in the output that you've recovered. Sometimes I want to change types, especially with numbers. This is called casting, and I can cast types of different forms. And you can see the example. If I say I want to take an int, such as 5, and turn it into a float, I can ask it to do so by giving it the special command float, the thing contained within parentheses, and it converts it. The other direction also works. If I want to take a float, such as 3.9, and convert it into an int, here you say, boy, there might be some choices. Python simply gives the whole number part of it. It doesn't round it to the nearest integer, as you might expect. If you want to build your own programming language, knock yourself out, you could do that. But it simply will truncate it down to that int. So I can convert back and forth. Now,
Yeah, I don't know if I can do this the same way, or yeah, let's try. Well, I just erase that, and here we go. So he did float 5, so float. Nice dude. Float. Oh, it do give me, yeah, float. Nice. Y, yeah, yeah. So 5, float the 5. Yeah, it's, I don't know why. Let's try print the same of last time. Parentheses. S, I did save it, and run, Forest, run. Yeah, well, give me 5, it's the same. So I think we have to do print. They said it's not a problem, it's the something combination with VS Code and what's the other, man, the professor is using. It's not, they are not the same thing. Yeah, I don't know. Continuing, yeah, go.
once I've got
So there, yeah. So this is changing the nature of the object. So when you read the type, you ask the computer for the what does this present to you as what he call it an integer. So it's an integer for him. And when you do use this command for changing it, you change. Okay, nice. Okay, good.
these things, I can start putting things together. And in particular, here's a legal expression, 3 plus 2. That has a value associated with it. And in fact, that expression is to take the 3 and the 2 and apply the arithmetic operation of addition to them. And when I evaluate it, it simply returns out 5. Makes sense. Sometimes I might want to use something that's going to print. And I can type, for example, print, which controls output to the console by saying print 3 plus 2. A little bit of a difference. And in fact, there's no out here because no value is returned. Print returns that none type and doesn't print anything out. It just printed something. At this stage, you may be saying, well, why do this? Why the difference? What we're going to see is when we're in the middle of a computation and we want to print something out to the shell, we can use a print command to do that. If we just return the value, that goes back into the computation to be used for the next step. And so in the simple first case, the whole value of the computation was 3 plus 2 equals 5. It was printing out 5. In the second case, the side effect is to print something. The value returned is nothing. There is no value. We'll come back to that as we go along. I've already hinted at this, but now we can start putting things together. To combine objects and operators into expressions, we use a standard form. And the syntax is simply an object, an operator, and another object. Any expression like this that is syntactically valid has a value, which is itself a type. So we talk about the types of scalar objects. We talk about the types of more complicated expressions. What would those expressions look like? Well, here's the first set of them. There's a lot on this slide, but you're going to get used to them, and most of them
Whoa,
make sense.
whoa, whoa, whoa.
If I want
Okay.
to add together either two ints or two floats, my expression is to have two numbers, as I just did, 3 plus 2. The value associated with that is the combination of adding the two things together. I can subtract, I can multiply. And for these examples, if both I and j are ints, the result is an int. If either of them or both of them are floats, the result is a float. And let's look at an example. If I do 3 plus 2, I get 5. If I do 3.0 plus 2, I get the float 5. So Python is always using, if you like, the higher level representation when it does those kinds of operations. Division's a little trickier because I have both standard division, which will be a float, and I have integer division, which will be the quotient without the remainder. And let's look at two examples. If I do 5 divided by 2, I get 2.5. If I do 5 with 2 slashes divided by 2, I get the integer part, which is 2. The 0.5 is thrown away. And if I wanted to get the 0.5, I could do 5 remainder 2, which is the percent sign, and that gives me the piece left over when I divide those two pieces together. Finally, I can raise something to a power, and that is done right here with I 2 stars j. So 1 star is multiplication, 2 stars gives me power. Once I've got that, I'm ready to start putting together pieces. In particular, I've got different operations, so I have to think about how do I put together pieces in ways that control what I want.
So I do think everyone get that point. I don't know. I thought it was easy for me. These kind of operations. So yeah, maybe. Anyone want to? I don't know. I'm talking with no one actually. Yeah. Okay.
So 1 star is multiplication, putting together pieces. In particular, I've got different operations, so I have to think about how do I put together pieces in ways that control what I want it to do. And here we're going to use parentheses to tell Python in what order to do the operations. There's a precedence to those operations, and those are shown right down here, going in this order. Exponentiation, powers, are always done first. Then multiplications, then divisions, and then finally additions or subtractions. And overall, it's done in a left to right order as it appears inside the expression. And that means that as I change where the parentheses are, I'm changing the order in which I'm doing things. So to do an example, if I take 3 times 5 plus 1, that's going to give me 16. And that's because the multiplication is done first. 3 times 5 gives me 15, and then the addition is done to give me 16.
Wow.
On the other hand, if I say 3 times, and then in parentheses, 5 plus 1, the parentheses say reduce this expression first. Add 5 and 1. That gives me 6. And then do the multiplication, which gives me the 18. As a consequence, I can create very complicated expressions, and I will simply use parens, open and close, to define what operations to do first. Always simplifying inside out before then using the operator precedence order in order to decide what the expression actually means.
Okay. So that was nice. Jumping for videos. 2 left. Go.
So we've now seen primitives. We've also seen means of combination. Simple arithmetic things, expressions that we can use to.
Yeah, so actually I am doing this because I start to be worried if there is publishing restriction or stuff like this. I don't know, maybe. So I'm doing this. Yeah, forget about it. I don't think there's nothing. We are learning.
Compute values. I said earlier there was one last piece, abstraction. Ways of giving names to things. So I can refer to a value just by its name and reuse it. We're going to see other kinds of abstractions as we go along, but that's probably the most important first one. And so we can now introduce that into our programming language. In Python, we do an assignment using an equal sign. And you see an example of it right here. There is an assignment of a name to a value. And in particular, the value will just be computed the normal way. In this case, it's simply that float. That's what we call a variable. It's a name. And the equal sign gives us an expression called an assignment that says bind to or associate with the name pi the value 3.14159. Once we have that, we can use pi wherever we would like. So in fact, if I go over to my machine and I do the same thing, I say pi is equal to 3.14159. If I now ask for the value of pi, it prints it back out. I've bound pi to a number. I can do other things. I can give an approximation to pi, and I want to put this one up because I want to remind you that if I were to use double slash, I would get just the expression 3, but here it's going to give me something a little different. And if I do pi approx,
Okay.
say 22 divided.
So I want to take some notes. هيقلب ولا طيز؟ شو حلو القلب شو هالطيز. طيبة قلبك. نايس.
Divided by.
So
7.
I do think I didn't make balls. Oh shit. It's okay. It's okay.
And I ask for that value, I get a little bit better, or maybe not better, representation of pi. That value is stored away in computer memory. It's in something we call a name table, where the variable pi has associated with it a value. And as we said, we can just retrieve it by asking what's the value associated with that name. Once we have that, we can start putting together more complicated expressions. So why will we give names to values of expressions? A couple of reasons. One is I want to just reuse the name and not redo the computation to get the value. If I actually had some very complicated arithmetic expression that reduced to a simple value, I don't want to redo it every time. I just want to give it the name.
Okay.
The second one is it can give me code that's much easier to understand. The name ought to be informative. It lets me think about what it's telling me about what this represents. And finally, it's going to be easier to change the code later if I've just got a name and I want to change the binding of the name and reuse it. So here's a simple example. I can bind pi to a value. I can give a radius, say 2.2, and then I can compute the area, pi r squared, and that'll give me a simple little computation. Those expressions also tell me something about what I'm trying to capture, and so those names turn out to be really valuable. One of the things to keep in mind is that this is simply following the sequence of steps we talked about. It's not like doing math. In programming, you do not solve for x. So, for example, in this little example, I define pi to be 3.14159. I set up a radius. This is just a comment. We're going to come back to that. That hash sign says it's just something that's going to be there for me to read. The computer doesn't do anything with it. I can now compute the area. And then I can decide I want a different radius. And in fact, look at this expression here, because what it says is get the value of this expression, which is what's the value of radius? 2.2. It's the value of 1. Add them together, that gives me 3.2. And change the binding so that radius is now 3.2. This does not change area. It's not like a set of mathematical expressions. It's simply following the sequence of instructions we gave it. And that means that if we want to do something different, we would need to recompute area. Again, I just want to repeat what we said because it's important. An assignment statement says, find the value on the right-hand side of the expression, take the name on the left, and assign that name that value. One last thing, we're going to see a lot of shorthand here. That expression, adding 1 to something, it's something we're going to do a lot. It's called incrementing. And so there's a shorthand, which is you could write this instead as just plus equals. And that is simply short for saying radius plus equals 1 is radius equals radius incremented by 1. The last piece here is you saw we could change the bindings. I can rebind a variable name in a new assignment statement. The previous value may still be around in memory, but it's lost. There's no handle, no way to get to it. And as we just saw, the value for area doesn't change until you tell the computer to do the calculation again. Another way of thinking about it is, if this cloud is my memory, when I do a binding for pi, it associates the name pi with a value off in memory. When I do radius, I get the same thing. When I compute area, it looks up radius, squares it, multiplies it by pi, and then associates the name area with that value in memory. And now, if I change radius, it loses that first association and creates a new one. But area hasn't changed. If I wanted to recompute the area for this circle, I would need to do another call to area to make it happen.
Okay, so that was nice. I want to, just this one.
When I do a binding for squares it, multiplies it by pi,
No,
but it's lost. There's for area. Another way of thinking about it
Where
is
is it?
if this, the last piece here, and so there's a short
yeah.
hand, which is.
I think it's we're good. For me, it was nice. It was not so hard. So I think this is the last video in this, and after that I'm going to do a pause, solving all the problems, and heading next to the, well, I'm learning stuff. Let's go.
So we've now seen the beginning of programming. Simple expressions, ways of putting them together into more complex things with means of combination, and the very first version of abstraction, giving names to things. But so far, all we've been able to do with these pieces is just behave like we're a simple calculator. We can do arithmetic. Let's add one more piece in, which is the ability to make decisions based on tests. And for that, we have to compare things. We have to decide, am I close enough to square root that I'm done? Am I close enough to something else that I'm done? So we have to be able to compare things. And since so far we've just talked about numbers, what are the comparison operators for integers and for floats? They're the things that you might expect from arithmetic. If I and j are any names of variables, they have values as numbers, then we have ways of testing if something is greater than something else, if something is greater than or equal to something else, less than, or equal. So is 2 less than 3? And if I do a simple example over here, 2 less than 3 returns true. That's good. 2.0 greater than 3.0 returns false. Also good. Is 2 less than or equal to 2 returns true. On the other hand, is 2 less than 2 returns false. Simple comparisons. I also want to be able to tell when something's equal. And you might think, oh, that's easy. Is 2 equal to 2? Wait. We already used equal as an assignment statement. So that won't work. And as a consequence, equality is done with double equal. Is 2 equal to 2? So for example, 2 equal to, oops, try that again, returns true. And then finally, if we want to know is something not equal, we use the exclamation point followed by the equal sign, often referred to or pronounced as bang equal or not equal. That will return true if I is not equal to j. Simple comparisons. They're going to let us build the very first kinds of programs that are going to let us make decisions, because based on whether something is true or false, I'm going to be able to decide which operation I want to do next.
So it's bigger than, smaller than, what do we call it? Greater than, and smaller than, and yeah, this is the, so this is equality, and I have to use the mouse because you do not see me, I'm not on the board or something. So this is the equation, equality. So the equation here, this equation is like the main, the main equal sign, the equal sign that we use normally, because the equal sign here is normal equal sign is for giving an object, assigning an object, I think, yeah, maybe.
You're going to get a chance to explore all of these, but these make sense because they're simple arithmetic things other than that double equal sign, which, as I said, is there because equal is already reserved. Once we have logical expressions, we also need to be able to combine them. I might want to say, is something less than this and greater than something else?
Okay, that's
so if
confusing.
I have two expressions that are Boolean, so I can also combine them.
That's easy.
Using either and, which is true if both are true, or which is true if either of them are true, and of course not, which will be the opposite. Not A is true if A is false if A is true.
Yeah, so it's easy. Not A, so it's a true if A is not false. It's false, you know, like is A a number? A is not a number, for example. Not a number, A. So actually it's not a number, so it's true because it's a letter. So true if it's not, and false if it is. So when we say not a number 2, I'm sorry, I'm speaking like a computer guy. Or speaking like a computer. Not a number, and we will use 2 for the to assign it. So it's false because it's a number actually, and it's not a number. So because it's a number. Yeah. Wow.
Once I've got those pieces, I can put together more complicated expressions to decide tests. How might we use these? Well, here's a simple little example. This is actually a map of MIT. MIT students are always looking for free food.
So it's MIT, we get it, you're the best in the world, blah, blah, blah.
Imagine there's some food stored away somewhere at MIT, and I want to give instructions to a student to find them. All right, this is a complicated map, but we could use a simpler version of it. I've got my student. It's over here with his backpack ready to find that free food, which is way over here, and I want to think about how would I instruct him to get there. What would the...
I'm sorry, but you have an MIT backpacks there? Dude, that's lame, really.
tests be that I might want to use?
I have to shut up.
I might say, if you can go to the right, keep going to the right. On the other hand, if you get to the right and it's blocked, change and go forward. Unless both the right and the front are blocked, in which case go to the left. Unless all of them are blocked, in which case backtrack. Won't be perfect, I could still get stuck, but this will work pretty well to get my way through a maze. What I've just described are 4 simple tests to let me think about how I would instruct somebody to solve a problem, in this case trying to find the free food. Oh yeah, I need one more thing, which is to test when I found the food to know when to stop. Simple tests. With those ideas, I can put together the first kind of actually more reasonable or interesting program called a branching program. And it would say in that case of the maze, move forward unless a test is true. That test might be moving to the right is blocked. If it's not blocked to the right, I'm going to do one thing, keep moving forward. If it is blocked to the right, I'm going to move ahead. And a branching program then simply consists of a test, something that's going to return a Boolean true or false. If the test is true, it's going to have some code that tells me what to do in that case. On the other hand, if the test is false, it's going to have some code to tell me what to do in that case. And in either case, once I'm done with those pieces of code, I can pick up the rest of the computation. You can see why it's called a branching program. It takes one of 2 branches based on that test. In Python, we don't necessarily have to have the false block. We have to have the true block. If this is true, there should be something I would do. But if it's not always the case that I want to do something even when it's not true, I can skip that. With that in mind, I can start now building a little bit more interesting programs. And so here's a simple example. There's some pieces here we're going to come back to. Don't worry about them. Pieces like input, which is going to give me a way to read something in. But what I want you to see here are the tests. And the first case of a branching program is an if statement.
What the
That's a
hell?
special symbol. It is treated differently, and when first case of here's a simple example. There's some pieces here we're going to come back to. Don't worry about them. Pieces like input, which is going to give me
actually, I'm a little bit hesitate if I'm going to write this with him. Yeah, I will let him finish, and after that I will write this program
to read something in. But what I want you to see here are the tests. And the first case of a branching program is an if statement. That's a special symbol.
I don't know if I should do it now or not. Yeah, maybe. No, I will let him finish. I think it's better for me and for you. Actually, never mind. Let's continue.
It is treated differently, and when the Python evaluator sees this, it says, given that's an if, I'm going to evaluate this expression, which should return a Boolean. It says if the remainder of x divided by 2 is equal to 0. Notice the double equal sign there. If it's equal to 0, if that is true, then I want to execute this set of code. it's going to print out a blank line and then print out the word even. If it's not true, I need to tell it what to do, and I use the special symbol else for that. These are often called if-else expressions. If this is true, do this. Otherwise, do that. And here, again, I've got a block of code. In this case, it's going to print out a blank line and then the word odd. In either case, when I'm done with all of that, I'm going to go down to the rest of the code, which is just going to print out a simple thing that says I'm done with this conditional. You could type this in and run it. I invite you to do that. But what I want you to see here is
So yeah, okay, I'm going to do it.
this if-else structure. And I said in a branch there should be three pieces, and you can see them. There's the test. There's the first block, that's the true block. And there's the false block. Now, how did I know, or rather, how did Python know those are the blocks? Because of this indentation right here. The fact that those lines of code are inset are important because it tells us that's an entire block of code. And when I get done here, I'm going to pick back up the rest of the else. And more importantly, when I get done there, it tells me where the rest of the code picks up. Simple example of a branching program.
Stop.
Code, which is just going to print out a blank line, and then first case.
So actually, guys, I'm going to do it with you. So I already told you I think I can do this very fast. So I will test my skills. Math input. So enter something. I don't know, something. Yeah, something. So enter. No, I have to enter. If x. So enter a number. Yeah, I don't know. It's not a problem. Let me do this more bigger. So wait. Next, if we can divide this, if we can divide this number on where is, I don't remember, where is it? So the 5. I have a new keyboard. If we can divide it on the remaining of the division on 2 is 0. That means this it's we can divide it, so it's an even number. Print parentheses. So I don't know what is this. Yeah, I don't know. I will do this and print even. I don't know why he's writing like this. So let's write else. I don't think it should be like here or something. So else print semicolon and print odd. And I think I have to do the same. print finished, for example. Yeah, and I am going to do save, and I am going to go to my terminal. Where is it? Where is it? It's here. It's here. It's not here. I don't know how to delete it. Remove this, for example. Yeah. Okay. Where is my show open editor? No. Run. Yeah, run. Invalid. So yeah, I do think we have to do this. What? Why? Yeah, I don't know. I do think we have to do this because it's weird. I don't know. Programming language is weird. Save. Run. Yeah, enter something. So let's do 50. Trace back. Print. Oh là là. Putain, ça c'est quoi ça? Enter something. 50. So it's even. Finished. Even number. Finished because it's, yeah. Let's do it. Let's do other way. The other way. So no. 71. Enter. Oh, finished. Nice. Very nice. And going back here. I don't know. I'm going to let it here. Yeah, whatever.
Of our branching, and again, notice how the
whoa.
I could have multiple elif steps. Again, don't worry about and run that piece. That's a Boolean, and the copy by 2 and not 3, or by 3 and not 2, and run that piece. Again, I invite you to type the false block. True?
I don't remember where were we.
Said in a branch there should be 3.
Yeah. We are here.
Now, how did I know, or rather, how did Python know those are the blocks? Because of this indentation right here. The fact that those lines of code are inset are important because it tells us that's an entire block of code. And when I get done here, I'm going to pick back up the rest of the else. And more importantly, when I get done there, it tells me where the rest of the code picks up. Simple example of a branching program. I've already said this, but I want to recap it. I've got a test. It evaluates to true, when in fact in this case x divided by 2 has a remainder of 0. As I've already said, notice the double equal sign rather than a single equal sign to do the comparison. As I've also said, the indentation is really important. It tells us what pieces are associated together. And notice how that indentation gives us a nice visual structure for seeing where the code is, to see the semantic structure of the code. What's the true block? What's the false block? Now, it turns out that you can have nested conditionals. Inside of a block, I could also have a conditional. And that's perfectly fine. It says if this is true, then I'm going to go in and look at this portion. And if this is also true, I'm going to do that. On the other hand, if this is true, but this is false, I'm going to jump down here and run that piece. Again, I invite you to type this in and try it. But it's going to do something that, based on what the value of x is, prints out whether it's divisible by 2 and 3, by 2 and not 3, or by 3 and not 2, as it runs through that sequence of branches appropriately. And finally, we can have compound Booleans. As I said, I have things that can be combined. This is a Boolean, that's a Boolean, and the combination with the and also gives me a Boolean. So in this case, if x and y, if x is less than y and x is also less than z, then the combination is true, and I'm going to print out a particular thing. Again, don't worry about what this actually does. What I want you to see is the structure.
Yeah, I'm going to do this also, dude. Yeah, I do think I have to do this. Well, actually, I'm just trying to understand how this does, how this work. Yeah, so let's do this. Let's do this. Let's do this. I don't know what is this. Why? Why do I have this? Let's don't save. And file. Open file. Open. It's still here. Why? Save. File. Open. Yeah. Okay. I don't know what was this. So we are already in this. So if x small I don't. Where can I find this? Yeah, there's it. And x is and x smaller than that's the thing. Oh, okay. So I'm just going with him to see what's. So print x is least. Is least. Okay. Print x is least. I don't have no clue what is least. What is least is. Elf. I have no clue what elf is. Y. Z. Elf, okay. Print. I don't know if, yeah, okay. Print y is least. Else. I don't know what this is. Else. Why? So I don't care. I don't know what I'm doing. I have no idea. Print. Z. I'm sorry. Z is least. So save, run. Elf. Yeah, I do think I know what is the problem. Actually, here I have to do this. Yeah, I already did some programming. Yeah, whatever. So X is not defined. Yeah, I don't. I think we have to define them in the beginning before. Oh shit! Control Z. How can I shift them all? I can. How to shift? How to shift all and one? Yeah. So let's do it. How to shift? Shave. I don't want to shave. Shift. In a new line all the code in Python using yeah, there is no I in using the C code. It's like God, like quoi? Ah mais c'est quoi ça? Mastering the selection and editing. Yeah, let's go with the first one.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
Yeah, shut up.
Hi there, it's Peter here again, the guy who makes models for front-end development. In this VS Code tutorial, you will learn how to expand and collapse, or collapse and expand block of code, how to select multiple lines, how to move them, how to duplicate line, how to use multiple cursors, and much more. But before we do that, don't forget to hit the like button and subscribe to the channel for more videos like this.
Another way how to speed up your front-end development workflow is to learn all the keyboard shortcuts to quickly select different parts of your code, and that's exactly what we will focus on in this video.
Focus.
The first one is Control
Focus. I'm sorry.
Command plus Shift and arrow left or right will quickly expand or shrink the selection inside of your HTML tags. This is very handy, especially
Yeah, dude, we
when
don't
you
all
want to
have
quickly select everything what's inside of the li or heading 1. Another example would be selecting inside of the title and changing it to a custom text. Again, I'm using the same shortcut, Command Control Shift and arrow right. Now if we go back to the JavaScript file and keep pressing the same shortcut, you'll see how we selecting the parent h1, then the following parent container, then the return statement and the render method. If we keep pressing the arrow left with this shortcut, you'll see how the selection is shrinking. Alt and arrow up will move the current line, the line where the cursor currently is, up, and if we use Alt and down, we'll move the same line down. If we keep...
So it's Alt. I don't know. Let's do this and Alt right. Nothing happened. So Ctrl Z, Ctrl R. No, I don't think Shift. Yeah, Shift is. Wait, Shift. Yeah. Yeah, Shift here is like doing this. No, I won't. Yeah.
Pressing the arrow down.
Finish the
Alt and
video,
arrow
dude.
down. We're moving the line wherever we want.
But I don't know. Man, I don't have a Mac. Please.
The same command but with shift will copy the current line, so alt shift and arrow up and down will copy the current line into new line, so very handy if you quickly need to duplicate two lines. And if we use alt shift and up, the current line will be duplicated above the line we selected. Now let's say that we want to select all the words it in our content, and we can simply keep pressing command select it. Now let's say that we want to select all the words it in our content, and we can simply keep pressing command and D to select the next occurrence. But as you can see, we are also selecting the it inside of the git word and with, and obviously we just want the initial, the starting sentence. So let's see how we can add the cursor just to the line below. The keyboard shortcut for that is alt command shift and arrow down, and that will let us select the
Yeah,
it
dude,
just at the
I don't know.
start of the sentence, and we can then change the it to some other text. That's alt command shift and arrow up or down. To fold a block of code, you can use alt command and square bracket left or square bracket right. It's the same as clicking on these plus or minus icons. Depending on where you currently are with your cursor, the related content block will collapse, like we collapsing the container.
Wait, you're doing stuff. So how to do search? Search control. No, shift S for example. No. Search. No, I want to search. Help. Go file. Edit. Select all. I don't want to select all. Copy line. Nice selection. So select all culture. Okay. Expand selection. Shrink selection. Copy line up. Copy line down, move line up, move line down, to the lesson selection, add course above, add course down. What did I do? Wait, let's see this. So alt up, nice. So let's do this. There is nothing to do. How to that's I don't know what did I stop. Yeah. Wherever. Yeah, let's go back to our lesson.
Including one last piece, which is elif, also shorthand for else if. This says if this test is true, do that. But if this test is false, then see if this is true. If that's true, do that. But if it's false, then skip down. In this case, there's an else, and I'll always do this. I could have multiple elif statements. It's a way of giving me a sequence of tests in order. If this is true, do something. If it's false, but this is true, do something. If that's also false, but this is true, do something, and so on. This just then pulls them together. I've got a basic conditional. If this condition is true, do a sequence of expressions. A can also have an if and an else, or I can have an if, a sequence of else, and an else. And again, notice how the indentation tells us which things to do associated with which block of code. That indentation is how we are going to capture other pieces as well, and it doesn't have to just be conditionals. I could have something that has other statements inside of it, such as a print statement here. Again, don't worry what this code does. It's a simple piece of code to execute some simple comparisons on numbers. What I want you to see is how we walk through the branches. And with that, we now have the first kind of code. There's one set of blocks, inside of which I've got another set of blocks. And again, if this is true and that's true, I'll get to that point. But if this is true and this is false, so true here but false here, what happens? Oh, there is no code here, so nothing happens. It simply skips out to the end and jumps past. Again, I invite you to try this to see if it works the way I've described it. What I want you to see is the form of it. One other piece I want to remind you of.
Wait. Because I'm not understand. Yeah, I know. Maybe. Yeah, let's do it.
Is the fact that when we do
Actually, I don't know if I'm going to. Yeah, I'm going to do this after that.
comparisons, we need to use the double equal. Equal sign binds a value to a variable. Here I want to compare two things, and this is a standard place. I make it all the time where you'll get a bug. Don't worry when you do it. Python's going to complain at you saying you're trying to do a binding in a place that you can't. But remember, this is a place where when I'm doing a comparison, I want to use the double equal sign in order to make the comparison of two values and return a Boolean. Okay, what have we added? First simple kind of program. Branching programs allow us to make choices and do different things. But it's still the case that at most, each statement gets executed once. I might skip a set of statements if I skip over that branch because I don't get there.
I'm going to do this.
But remember, this is a place, which is else. I could have multiple else, or I can have an if, a sequence of else, and an else. And again, note which is a print statement here.
So matters in how you donate blocks of codes. Actually I'm a little bit pissed off because of this save and run. This is not defined. Let's do this. Let's do this. X float input, enter a number. I don't know what is this. Oh, that's really weird. I don't know what is this. Okay, so I don't know what is this. Got for example. No. I can't go to the definition, no definition. Let's try to. Is for the, yeah, there is something wrong. So I'm going to close the program and open it. Yeah, okay, so it's gone. I don't understand. Let's do it. x تساوي float. Okay. Please stop. Don't save. File open. Where is it? So I'm going to delete this. I really don't. Console. So Ctrl N and Shift S to first dot py. I redo this once again. Yeah, there's no problem. There is no problem here. So x تساوي x equals, dude, I'm speaking whatever. Float is float. Float. But parentheses enter. Okay, enter x. Y. Do you think it's the same? So I'm going to do whoop, copy, and no, sorry. What did I do? I don't know what did I do. Yeah, so y تساوي y equal Control dude. Copy and paste. And I do have it right here. And I have to, yeah, equal. Here is enter y. F x. Please write properly. Properly is y. That means burnt. X and R equal. X and y are equal. EQ, no, Q, U, A, L. Sorry. Yeah, if I did this. Actually, I think there is a problem here. If so, yeah, so I have to do what I have to do. What is this? Dude, what is this? You have to be fast at it. So, okay. If y if y is not equal to 0, yeah, if y is not equal to 0, Brent therefore xy is x on y. Okay, so there for x on y. So all this is why you did this. So all this is inside the parentheses. No, stop. And this is a calculation. So this is a calculation. Yeah, let's do this to sum it up. So this is inside the parentheses. This is will print, and this is an equation. This is a number. Actually, it will be calculated. Okay, so. This elf is going back to this if. So else if elf x smaller than y, less than y, we can print let's do this. Print x is smaller. Else, and this else is going to for this if. So at the end, print. This is what I remember. Print. Yeah, stop. Y is smaller L. It's L, stop please. Print, and this is the final one. Print. Thanks. No, I have to do this. Thank you. Thank you. So let's do this. Let's go. Yeah, this is nothing. X is the float of the input. Y is the float of the input. If x was y, if x equal to y, and xr equals. Okay, if inside this elf. Okay, let's run it. Let's run it. Let's run it. Enter x. X is 5. To y is 6. X is smaller. X is smaller. Okay, let's do the program one more time. Let's make them yeah, there is a flaw. Well, if they are equal and you want to do this, this is going to be 1. So let's do 5. Yeah, 1. I don't get it actually. Why? Yeah. I do think if we put this here, it will be nicer. No, it will be here because y is smaller than there. Yeah, like, I don't care. I didn't do this. Yeah, okay. So nice. Yeah, let's do this.
Here. Again, don't work through the branches. And that's true. I'll get to that point. But if this is true and this is false, So true here, but false here. To try this to see if it works the way I've described it, what I want you to see is the form of it. One other piece I want to remind you of is the fact that when we do comparisons, we need to use the double equal. Equal sign binds a value to a variable. Here I want to compare two things, and this is a standard place. I make it all the time where you'll get a bug. Don't worry when you do it. Python's going to complain at you saying you're trying to do a binding in a place that you can't. But remember, this is a place where when I'm doing a comparison, I want to use the double equal sign in order to make the comparison of two values and return a Boolean. Okay, what have we added? First simple kind of program. Branching programs allow us to make choices and do different things. But it's still the case that at most each statement gets executed once. I might skip a set of statements if I skip over that branch because I don't get there. But as a consequence of this, these are what we would call linear programs. They run in constant time because I execute each instruction at most once. And the maximum time to run the program is going to depend only on the number of instructions that I have there. Still valuable to make some decisions, but it's not going to give us the power that we want to really build interesting algorithms, and that we're going to get to next time.
Okay. So I'm not going to solve this right now. Actually, let me pause for a quick bit, and I want to see the questions. So yeah, I'm not going to do them right now. I'm going to do them when we're finished, because we're approximately 2 hours. That is a lot. So we're going to hit our next target and do all the videos, and after that I will finish doing all the questions. I don't think this is the problem set, so I'm leaving it to the end. I will not share with you. So I'm going to do this. We're going to do this. Let's go. Yeah, so, let's check out the just the long of the video. So this is 4 minutes, and this is 7 minutes. This is 6 minutes. There is no like something like half an hour or something. 5 minutes, 3 minutes. Yeah.
With these
Nice. 14 minutes. Shit. And that is
the notion of a
yeah, a total of 3 hours, I think.
this no
So it's like 5, 5, 5, 14. This is half an hour. Yeah, like we can do one more 1 hour left. Yeah, let's do it. Well, it's after that it should be 3 hours. Yeah, we don't care. We love to study. But actually, I do have to work. Yeah, tomorrow. Yeah, let's do it. Okay. Buckle up. Let's do it, guys.
Welcome back to 600, Part 1. In the first lecture, we started talking about computation, computational thinking, and we began to introduce simple expressions and very simple programs. In this lecture, we're going to add a new type. We're going to go back and look at branching as a key element in order to make decisions in algorithms, and then we're going to start introducing the first class of algorithms that are going to be really valuable, things called iteration or iterative algorithms.
Wait, what?
To do that, I want to just quickly remind you of things that you saw last time and that you need to keep in mind. First of all, variables. often called bindings. These were names that we had to which we could associate values. And we saw they were created by using a name followed by an equal sign followed by an expression that had a value. Why did we want the name? It could be descriptive. It tells us what that value is. It gives us something that helps us think about how we're going to use that. It lets us reread code more easily, and it certainly can be meaningful because it gives us a sense of how we want to use computations in more complicated ways. One of the things to remind you is there are certain words that cannot be used as variables. These are things called keywords, things like int or float. They describe a type. They cannot be used as a name for a variable. There's a set of these that we'll talk about as we go through, and you'll notice in Python when you type one of these keywords in, it'll show up in a different color, which is a hint that it's a keyword and not something you should be trying to bind as a name for a value. The value could be any legal expression that returns a value, and that's going to store information that we're going to use. And finally, we saw that we could update a value associated with a name by reassigning it using another assignment statement. The way we did it, just to remind you, was we compute the right-hand side of the expression. For example, here, the value associated with 2 is just the int 2. We then store it, sometimes we refer to that as bind it, to the left-hand side, which is the variable name. That creates a binding off in the machine of x associated with 2. But of course, we can also replace it with a new value. And here, again, if you look at the second expression, remember, we first evaluate that expression. The value of x right now is 2, so 2 times 2 is 4. That associates the the value 4 with the variable x, which says when I get around to then evaluating x plus 1, this is going to be 5, which is the value associated with y. Equal sign does the assignment. It creates those bindings for us. And as I just said, we're going to always compute the value first and then override the name if that value is actually used, or rather, if that name is used as part of the expression to get the value. You might think this is pretty straightforward, but we need to be careful about the order in which things are done. Suppose I got two variables named x
Please,
and
internet.
y, and I want to swap their values. The little sequence of expressions here looks like it should do the right thing, right? Wrong. Let's think about it. The first expression assigns x the value 1. The second expression assigns y the value 2. The third expression gets the value of x, which is 1, and assigns it to y. So I have x is 1, I have y is 2. I look up the value of x, I now assign it to y, so the 2 is replaced by 1. Oh, now when I do this expression, it says, what's the value of y? It's 1, assign it to x, and I replace the 1 with a 1. So it didn't swap them because there's a sequence to this operation. Okay? Doesn't do what you think it was going to do. There's a better way to do it, in fact, the right way to do it, which is to temporarily assign the value of y to the variable temp so that I can overwrite the value of y, and I still got that value around to restore in to x. So we need to think carefully about not only what do I compute as a value and what do I give as a name, but the order in which I do it, because if I lose a binding for a name, I can't get it back. But that reminds us then of how to do assignments, how to do bindings, and how to do the actual sequence of operations to create bindings associated with variables.
Okay, I will take some notes.
Welcome back
I
to
think.
600, part 1.
No, I don't.
In the first
think I
lecture,
take some
we
notes. Let's jump in. Next video.
So far, we've just been playing with numbers. Names for numbers, but basically just with numbers. Now we want to add in one more type of object. We've seen ints, we've seen floats, we've seen bools, which are ways of getting values back out of tests. The last thing, or the next thing rather, we're going to add in is a string. We'll see a few others as we go along, but strings are going to be valuable to us. And what's a string? A string is simply a sequence of characters. Letters, special characters, could be spaces, could actually be sequences of characters put together into words, put together into sentences. And those are all contained within either double quotation marks or single quotes. Let me show you some examples. I've got some on my slide, but let me show you some examples with my screen. I can give the name hi to the string HELLO space THERE double quote. those quotes on either end say, treat this entire sequence as literally a sequence of characters. And if I ask for the value of hi, it prints it back out, in this case with a single quote around it. As we said, we can either use double quotes or single quotes. Why? Partly historical. One would really work, but a place where double quotes are handy is if I actually want to use an apostrophe somewhere in a string. Because from Python's perspective, the apostrophe looks like an end of a quote. And so, for example, if I want to say, foo is, this isn't right, notice that the single quote does not get interpreted as the end of a quote, and I can put out the value of foo. Once I've got strings, I can put them together. So, for example, I could say, I'm going to give name the value Eric. I could certainly print out name. What's its value? There it is. But I could also put things together. And the next expression looks a little unusual. Greet is hi plus name. And when I print out greet, sorry, if I type properly, it would help. Print out greet.
Yeah, that would help.
It puts
Professor.
the two things together. Hi there and Eric. Two things going on here. The first one is, whoa, little funky to think about adding strings together. But just as we can add numbers together, strings have a natural way of getting combined. In this case, is to concatenate them together. To literally take the first string, glue the second string onto the end, that creates a new string, and I can print it out. But if you look at my computer monitor, it didn't quite do what I wanted. It said, hello, Theric. I have no idea who Theric is. I'd really like to have it say, hello there, Eric. And so I can get that by adding in a little blank space. And so if I type in greeting as hi plus a space plus name, then the value of greeting is what I wanted. Hello there, Eric. Really nice. Notice, concatenation, just as with numbers, could have multiple things in a row. So I can concatenate multiple things together as I did here. What we say when we talk about using addition this way, by the way, is we say we have overloaded it. We have had addition apply not only to numbers, but now to strings. Oh yeah, we talked about that earlier on. Remember when I said in the first lecture that the type of an argument, the type of an object, would tell an operation some important information. Here it does that because it's telling addition. If the two things are strings, concatenate them. It's also telling addition if I give you two numbers, just add them together using straightforward arithmetic. So I can use addition in multiple places to let the type of the object define what's going to happen. Once I have strings, I need operations on them. We've already seen the first one. We can do concatenation, but we can do some other things with strings. In particular, we can do successive concatenation. So if I type 3 times the string Eric, I get an echo.
Yeah.
3 versions of Eric are stitched together. So I can successively concatenate things together. It's kind of nice. And again, notice I'm overloading multiplication here. I'm saying multiplication of a number times a string is simply saying give me 3 versions or n versions, however many versions of that string put together. I can ask for the length of a string. And that makes sense. It tells me how many characters there are in that string. And that will include, by the way, counting spaces. So the length of hi there includes the space, not just the characters. It tells me how many literal elements there are inside of it. Strings have things inside of them. They're the first version of a non-scalar object in that I can get out pieces. And then, one of the ways I can do it is say I can index into it. So if I take the string...
I need to... I don't know. Never mind.
Eric, and I want to get out the first element in square brackets. I can say, give me the first element, and it gives me R. Wait a minute. That's not the first element. The first element's E. In Python, we have chosen to decide to start counting starting at 0. So if I want to get the 0th element of Eric, I would say, give me the 0th element. And there it is.
Nice.
I've already bound name to be Eric. So notice, by the way, I could ask for the 0th element of name, and it gives me the 0th element of the value associated with name, which pulls back out the E, exactly what I wanted. If I try and index beyond the length -1 of a string, I'm going to get an error. And that's because I start at 0. So even though this is of length 4, if I take the string Eric and I ask what's the 4th element, it gives me an error, something called an index error that says you tried to go too far outside of it. One last thing about strings. I can certainly get a single element out. I might want to get a chunk out of it. And so I can slice a string apart by giving it a somewhat funky looking expression. I take Eric, and again, in those square braces, I give it a starting point, which is 1, and a colon, and then an ending point, in this case 3, and it gives me the first and second elements of the string, R and I. I can choose to say everything starting at the beginning. I could use that as a 0, but I can also do that by saying give Eric with nothing before the colon and just 3, and it gives me all the elements up to, but not including the element number 3. And similarly, I could do it by saying take Eric, give it 1, but nothing after the colon, and it gives me all the elements starting at element number 1. And if I just want to make a copy of the whole thing, I can say open square brace, colon, close square brace, and it gives me literally a copy, not the original, but a copy of this entire string.
Okay. It's very important. Make some attention, guys. So, jumping in, next video.
As we've already seen in our programs, we need to be able to both read input in and print stuff out, or return values. I want to now spend a little bit more time on that. We show a very quick example of it earlier on, but I want to come back to that to be able to give you a sense of how you can control that. So let's start with output. I want to be able to print something to the monitor as I'm doing computation, not just at the end of a computation, but perhaps partway through that. And here we have a keyword called print that's going to do that for us. And I've got a simple little example here, which I'm going to run on my machine. I'm going to define x to have the value 1. I could just print x. So the keyword print, followed by an open paren, followed by, in this case, a name x, followed by a closed paren, simply prints out that value on the screen. Kind of trivial in this case. But I want to show you some examples of how I could control the print a little bit differently. So I'm going to define x string to be the string x. And notice what I'm doing here. X is an int. str is going to actually cast it into, or convert it into, a string. That is the symbol x. And I'm going to give it a name. In this case, I've called it x_str. If I do that on my machine, I've now got a binding for x string. Now I can do printing, and printing here can take multiple arguments. You can see it on my slide. I'm going to print out a combination of this expression, that expression, a sequence of expressions, all separated by...
Wait, I need to take notes. Because if I didn't do that now, I will... I don't know. No. Maybe... No, okay.
Let's see what happens if I do that. So I'm going to do print of my favorite number is a comma to say I've got something, and then I'm going to give it x, and then I'm going to give it a period enclosed in double quotes, and then I'm going to give it something that says what's the actual value of x and x.
Ah, I'm sorry.
Sequence of things.
Why this happened? F exit. What is this? No, let's take it here.
Print it.
Let's do it here.
I get something pretty funky. It says my fav num is 1. Oh, but then there's a space before the period. And then it says x is equal to 1. What happened there? Well, what happened is that print is literally printing each element followed by a space. And in particular, x has a value that's going to show up separately from the period. On the other hand, if I give x as a string, it's simply going to put the two pieces together. And so I can do a second kind of print, which is I can say print my favorite number is, and then I'm going to add to that or concatenate x string, and then I'm going to add to that period, add to that the last part of the string, x equals, and add to that x string. And if I print that out, I get something a little bit better. In fact, I blew it. I wanted to have a space between the period so that it would actually print it out as saying my favorite number is 1. So let's do that one more time. Print my favorite number is, and a space, concatenate x string with period and a space, concatenate that with x equals, with a space at the end, and concatenate all of that with x string. And I finally get what I wanted. What am I showing you here? In the case of print with multiple arguments, it will print each one of them spaced apart. In this case, I am concatenating the entire thing into one long string and then printing it out, and I can control the spacing around it. So this is going to give me a way to give out input, or rather to give out output to the machine, telling me what I've done as I control it. What about the other direction? I want to bring in input. And here I have another keyword called input, not surprisingly. And it takes a single argument, which is a string. And its behavior is it's going to print out whatever's inside of those quotes, that string. It's going to wait for me to type something in. When I hit enter, it's going to evaluate whatever I typed in and return that as the result of the input statement. Typically, I'm going to want to bind that to something, so I can bind it to a variable name, like text. And if I try this, I can say text equals input, and I'm going to simply say type something. Notice what it did. It just printed out, type something. It's waiting for me to do something, and I can say foo. What did I do? I bound that to the name text. If I look at text, there it is. So if I wanted to really be annoying about it, I could then say print 5 times text. And there it is. Now maybe you're looking at it and saying, wait a minute, why are the double quotes there? Because I typed them in. Input simply expects everything to be a string. So I could do the same thing. I could say text equals input type something.
Wait, what?
Again, it's waiting for it. In this case, I'm simply going to write in the string bar. And what's text? It's just bar. And in fact, if I say what's the type of text, it says it's a string. So if I'm going to type something in, it's automatically going to read it in as if it's a string. But that says if I wanted to get a number in, I need to cast it. And that's what this last example does down here. Input, even if I type in a number, is going to interpret it as a string of the characters of the number. And so I need to turn it into an int before I actually use it.
Wait. Huh? Okay. Next video is the 40 minutes, I think.
So far, we've just been typing things into our Python shell. And for simple expressions, that's okay. But it's even there a little bit painful. And when we want to do things that we might like to run multiple times, or when we want to do things with multiple commands, we'd really like a better way to deal with that. And for that, we'd like to have a text editor. Just like an editor you'd use for writing Word documents, we'd like an editor into which we can type Python expressions. And in most cases, that comes as part of something called an IDE, an integrated development environment. I happen to be using one from Anaconda. IDLE's another version of it. And that IDE comes both with a text editor, into which I can enter things, I can edit them, and I can save them away. A shell, which is that place where I'm going to be able to interact and where I can load that information in before I do that interaction. And as we'll see later on, an integrated debugger. And I want to show you just an example of how I would use that text editor as part of the IDE. Your own computer may have a slightly different version, but you should be able to figure it out. Let me simply show you an interaction on mine. So on my computer, I have both a text file opened up as well as the shell. And here I'm going to type in a couple of expressions. I'm going to set x to the value 5. And then I'm going to create a little conditional. I'm going to say if x is not equal to 5. And remember, I'm going to close that conditional with a colon to tell me I'm at the end of it. When I hit a carriage return,
What?
the editor automatically indents, which is really nice. I know that the next set of things should be indented. So in this case, I'm going to say print out, I am here. I have no idea why, but it seems like a reasonable thing to print out. I hit a carriage return. I'm still at the same place, but then I'm going to put in an else clause. And notice it nicely indents back because the else should be at the same level as the if. And then I'm going to say print.
It's not doing that with me, actually. I don't know why. There was something here. Let's delete this. Yeah. No. All. So x تساوي صفر y تساوي واحد if x I'm speaking in Arabic, right? Shit. So x equals 0, y equals 1, if x equals 1, y. Let's do parentheses print x, y, print not number anything. So else yeah, there is something with this. What did just happened? No. So else. Dude, there is something happening here. Why? Yeah, I don't know. Let's try you fixing noisy code. Fixing if else in my conditional statement if no no, I don't want this. Fixing. This is how we write fixing, right? Fixing a broken heart. Yeah, this is exactly what I'm searching for. So fixing. Yeah, guys, you know what? I'm going to find the solution before after that. I am not going to else. Nah, I want to find the solution just one more time. So else something else, print, for example, print, yeah, number. There is something wrong. Let's run it. Yeah, there's, look, there's something wrong with it. So maybe like this. Run. Always. Always something wrong. Yeah, so fixing else in my VC code. Yeah, what? Fixing how fixing the lining up else statement in VC code. Let's see this. Or like, yeah, wait, let's do if else statement in VC code line. Python. No, Python. I don't want in one line. I want someone just using by if else statement using VC code. I don't want this. Want someone using VC code, Python. So VC Code Python, run with Python and Visual Studio Code. So let's see this. I want to see how
Hey guys, in this
someone.
video I'm going to show you how you can
I don't need the device, so I just want to see how is trying to write if or else statement. If he will write else or else statement. Wait, so I need to download anything.
want to install it straight away from
The Python extension is going to this. Yeah,
this
okay.
message. You can also go to this last option, which is called the extensions, and just click on this. Here also you can search for Python inside the search box, or you will see in the recommendation this Python plugin also. So for example, I just type here Python, and the first result here will be the Python plugin extension. You can also read more about this extension by clicking on this extension, right? So this is the same extension which is recommended by Visual Studio Code to us, which is this pop-up, right? So if you just click on the install button, it's going to install the Python extension, and you can see how many number of time it is downloaded. It is downloaded about 62 million times. So it's the most popular, or one of the most popular extensions which is provided by Microsoft. That's also important, right? So I'm going to just click on install button, which is going to install this Python extension. You can see some more extensions also here, for example Python for Visual Studio Code, which is also relatively popular. You can see 1 million downloads of this extension, and you can see many more extensions when you just type here Python. So for example Python preview or Python path. So now you can see that this Python extension is
I already
added
downloaded.
to our Visual Studio Code, and at any time you can also uninstall this extension by clicking on the uninstall button. So once this extension is installed, just go to your Explorer once again. I'm going to just close this page from here, and now you can also see some tips and recommendations from your Visual Studio Code editor, which is to install pylint extension. So this time I'm going to just directly click on this
Beeline. I don't think I did this. BY line. What was the name? Yeah, I do have a BY line. So there's nothing. Enter. So enter. Linter. BY. BY. That I have nothing. NT. Cloud formation. Python extension. Like. I'm not having anything actually. I don't know why. Well, it should. Linter BY line is not installed. do this. No extension, by lined. Linter. What is linter? So linter by or by linter for example. What is by linter? I don't know what is it.
Install button, which is going to install this pylint extension on our Visual Studio Code. So you can see it's installing this package, and you will also observe that this package is just a pip package, and you can see this command is already given on your terminal, which is pip install pylint for this user. So if you want to install pylint manually, you can also give this command using pip. So you can just write pip install pylint, and this procedure is same as what Visual Studio Code is doing for us, right? I'm going to just close this recommendation because we have already installed the Python extension for the Visual Studio Code, and now you can see that the pylint extension is also installed. So you can see this terminal is also available inside your also installed. So you can see this terminal is also available inside your Visual Studio Code, from where you can run your script directly. So I'm going to just close this terminal for now, and I'm going to show you how you can open it once again. You can go to the view, and then from here you can just click on the terminal, which is going to open the terminal. If you want to open multiple terminal, you can just click on this plus button, and you can see want to open multiple terminal, you can just click on this plus button, and you can see there are multiple terminals open which you can switch.
So I'm going just to check open file. What did I do? No, file open. So I'm just checking if where is the extension? Yeah, so no extension found. Maybe this one.
Using this menu bar. So I'm going to world here. So you can see this output hello world. Also, if you want to increase the font size, you can just go to file and then go to the Python 3.7.4 64-bit version is used.
No, not the ads, not the ads, not the ads, please. Yeah, sharp.
Python here, or when you drop this menu, you will be able to value of that expression. So I have just added this expression, and it shows me hello world. Also, there is a call stack here. Now you can debug your code. You can also restart your debugging by just pressing the restart button, and it's going to do write, for example, a function. Use the IntelliSense. If the IntelliSense is not working, you just need to relaunch your Visual Studio Code, because sometimes you code and then try to use this.
So if else and yeah. This is no. I don't want C programming, dude. There is problem. There is lots of problems. Yeah, maybe this one.
So you're a programmer. You're coding along, and you run into a problem. You do a Google search and start scouring.
Hey there, how's it going everybody? In this video we're going to be learning how to install Visual Studio Code and set up a Python applications, how Git integration works, look at unit testing capabilities, and a few other things. So I've had a ton of comments and requests to cover VS Code. If you do, then they might not be the same ones. So for example, this is recommending Azure repos to me, and it tells me this quite yet. But we will take a look at this here in just a bit. Now, and we'll take a look at this here in a bit as well when we debug some code here. Okay, so right off the bat, it shows us some recommended
I'm sorry guys,
extensions
but I'm
here at
trying
the
to
top,
find the
and then
solution.
it shows us some popular extensions right
Yeah.
below this.
I'm doing
Now, you might not have these recommended extensions. If you do, then they might not be the same ones. Here, and just open up my project, and now it's going to open that up in a new window. Now I'm going to close down. Talking about our user settings, let's also make some changes to other global settings as well. So let's look over here in the sidebar. So to do that, we can see that this looks pretty good right now. It gives us a Python. I like to see my default settings while I'm editing my user settings. So I will set that to true, and you can see that we have a Python 3.7 called VENV here, and we can see that it gives the location. Now, if you're using a virtual environment that's located somewhere else, CoreEMS.com, and now I'm going to print out the status code environment, and then print this out. So we can see here. That it is Shift-Alt-F. So I'm going to use. Okay, so now
Dude,
with that
please
installed,
use one.
then we should be able to format our code just by using that Shift-Alt-F. We'll also auto-format for JSON and other languages as well. And those are all things that have requests installed. Then that would fail, even though I do have requests installed in my virtual environment. So I can do a code runner, and again, I can hit Control Space to make this autocomplete for me. And I want to change this clear previous output. I want to change that to true because email. So my email is Corey M. Schaefer at.
Seriously, dude,
like
what
that.
is this?
Then we'd actually be able to see that increment each time what unit testing framework we want to use. PyTest is very popular. I'm using unit test in this example, but you can select whatever it is that you're using. Now we're going to choose the directory that contains our unit test.
I will see this.
On today's Visual Studio Toolbox, Tyreek is going to show us how to get started with Python development using Visual Studio Code.
Another cool thing is by default when you install code on there, and now what's really cool is because I have VS Code on the path on my Windows, but I actually want to show you a web app that I have with the virtual environment already created.
Okay, cool.
So let's actually answer your question right now. Cool. And so a couple of things to immediately notice about. So it's saved when I opened it back up. What's even better is that I could actually activate.
You have no else statement.
I have not only
The yellow squiggles that are appearing here. These yellow squiggles are what we call linting messages, and cards called startup. So what I actually want to do is I want to tweak this path a little bit to actually point to my startup file that is creating my Flask app, which. And we have a list.
Yep.
Notice that I clicked to the left of the line number, which is called the gutter. For those of you who are used to debugging. It's going to be the same kind of feel. For those who aren't, fear not. It's super easy to get started with the debugger. So to start this, there are a couple of ways I can run my debugger. And I'm going to just collapse that so I can give you full attention here. I can keyboard shortcut F5. And so what I'm going to do is I'm going to start doing that, which means that it did something magical. And what it's done is it's hit this breakpoint inside of our I have some different arguments here which are on by default. And to variables here.
I don't know. I just tired of searching for stuff.
No,
I will try to solve this later. Yeah, give me this.
Not. Now I want to run this, meaning I'd like to load this information into my shell. There are a number of ways to do it, but the easiest one is if I go up to my menu item at the top, there's something called Run. And if I click on that, it gives me a set of options, including something called Run. And I hit Run, and it's going to ask me where to store that file. I'm going to give it a name temporarily. And it said I didn't like that. So I'm going to try it again, giving it a place that I know I can store it to. Let me do that. I want to pick a particular place, save it away. Oh, nice. If you now look at my shell, it's actually evaluated that code. It turns out that I have other options here. Under that menu, I could run the entire file, or I could pick something out and run just a portion of it. I could select a thing using the mouse or run a line. One of the other things I'd like to do is to run that file multiple times. So for example, I could say I'm going to change x from 5 to 6. And now, turns out on my machine, there's a shortcut, which is just function F5. It may be different on your machine. It automatically saves the file away, executes it, and again, on my shell, I've now seen a printout. This is going to be really nice. It's going to let me have easier ways to edit files, edit code before I run them. And so what you have then is that ability to have both a place into which you can type things, save them away, and a place in which you can then evaluate them in order to do the kinds of computations we've been discussing.
Okay, let's jump into the next video.
These new data types in mind, strings. With these new data types in mind, strings, with some of the other pieces we've added in, let's go back and just remind ourselves about branching.
Yeah, just I'm trying to find out this. Yeah, I don't know. Where is the? Oh, that's not working. I don't know. So depressed. And I will find a solution.
Programs so that we can build on that to start creating.
Yeah, how much do we have left? I have 2 videos. This is the 40 minutes, and this is like, yeah, I don't know. This I will finish this, and I will go. I think I need to sleep.
Iterative programs. So just to remind you, what's a branching program? It's something where I have a conditional that I test. If that test returns the Boolean value true, then I have a block of code I'm going to run. If it returns the Boolean value false, I got something different I'm going to run. And I'm going to simply take either this branch or that branch and pick up the remainder of the code. We've already seen a simple version of that with an if. To do the testing, we had comparisons, things like comparisons on ints and floats. These are simple numerical things. I will simply remind you again, the double equal checks equality, equal sign does not. And we had logical operations to put things together. With that in mind, we could start then building the simplest of the branching code, which were either if statements, which says if this condition is true, execute a set of code, an if else, which said if this condition is true, do this, otherwise do that, or the more general if else, which says if this condition is true, do this. If it's false, check to see if this condition is true, in which case do this, and keep doing that until I get through all of the else clauses, and if all of the conditions are false, pick up the else clause and do the rest of that. It's just repeating what we've done before, things that you've already seen. With that, though, I'm still stuck with things that can only flow through code once. I can take different branches to get there, but I can't go back and do something again. And let's think about where that might actually not help the way I'd like. As I said, simple branching programs just make choices. Sometimes, though, I might want to do something over and over and over again. How would I do that? Well, imagine you're writing a simple little video game. And part of that game has a character that gets lost in some woods. And I agree the graphics here aren't great, but you get the idea. I'm stuck in a set of woods. What I'd like to do is to say to the character, if you go right, you're going to get back to the same place. You're going to be stuck in the same piece of the woods. How would I write that as code? Well, you could say, gee, I could have an if statement that says, if I'm told to go right, here's a set of things I want to do. Otherwise, if I go left, I'll get out of there. Okay? But I want this to be something that if I keep going right, I keep getting stuck in the same spot. All right, you say, gee, that's easy. I could have another if statement that says, if the command is still exit right, do something.
I'm sorry.
On the other hand, if I exit left, I'll get out of the woods. But I want to do that again. If I'm going right, I want to keep doing it. You can see the problem. I want to be in literally an infinite loop in this little video game that says, if I'm going right, I'm always coming back to the same spot. How would I write code to do that? Well, I could say, I'm going to assume that a character doesn't push go right more than 100 times. And I could write literally a big loop here, not a loop, sorry, a big sequence of ifs that was 100 deep. But maybe somebody's really persistent and they want to do it 1,000 times. You can see my problem. I don't want to write code when I have an indeterminate number of things that I want to do. I need a different way of controlling this, and I have that. It's called a while loop. We're going to look at it in detail, but the idea is that I'm going to say, here's a check, a condition. If it's true, I'm going to do this, and I'm going to go back around and do it again. And I'll keep looping around and around on this while until this condition is false, in which case I'll jump out and do the next kind of thing. And that says no matter how many times I go right, I'll always be in that loop until I finally go left and break out of it. So I can control the flow. Now for the first time, not just in a linear way, with something that lets me check conditions. And so the format of a while loop is very simple. There's the while expression. There's a test that's going to return a Boolean value, either true or false. And then with indentation, a set of expressions I'm going to evaluate. And the performance of this is exactly what I just described. If the condition is true, I'm going to do all the steps inside that code block. I'm going to go back up and check the condition. And I'll keep going through that loop until the condition finally comes out as false. All right, how might I use that to do something a little more interesting than trying to get out of the woods? Well, first of all, let's fix the woods. Here's a nice little piece of code that will do that for me. The first one says, input based on this prompt an instruction, left or right. So n's going to be either the word left or the word right. Notice what the while loop says. It says if n is equal to the string right, then I'm going to execute this block of code, which simply again says, you're in the lost forest, go left or right. And notice what that while loop will now do. As long as n is equal to right, it will keep prompting me, asking for an input until I finally type in left, at which case this will be false, and I'll jump down and pick up the print statement. I can have an indeterminate number of times here. It's still always going to do the same thing. A little brain damage, but it's still going to do the right thing, and that's kind of nice. Now, let's see how we might use this then in other kinds of things. So here's a while loop. And notice what I need to do inside a while loop. I need to set up a variable outside so that I can test it and then do some pieces. And I need inside to have something that actually changes that variable. Otherwise, I'm never going to get out of the loop. And we can see what this does. If I type this in to my Python shell, I can set n equal to 0, which is done. And then I can say, while n is less than 5, colon, I'm going to print out n, and I'm going to set n to n plus 1. Cool. It just did what I'd expected. Starts out with n equal to 0. Is 0 less than 5? You bet. So it prints out n, changes n by 1, goes back around and checks again. Is 1 less than 5? You bet. And you get the idea. That pattern is something that we would use pretty regularly. That pattern is also slightly annoying, because what if I forget to set n equal to 0 before I start? I'm either going to get an error, because n isn't bound to anything, or I'm going to get a performance I don't expect because n has got some value I didn't expect. Similarly, what if I forget to increment? I set n equal to 0, and I say, well, n is less than 5, print n. Well, I'm going to print out 0 a billion times until I finally stop the machine because I haven't incremented. So it turns out there's another form that we're going to use that is much more convenient, and that's called a for loop. And the for loop has a particular syntax. It has a variable. It has the keyword in this case. And then it has something we're going to come back to in a second, but an expression. And what for does in this case is it is going to work through all of the values returned by that expression one at a time, executing the body of the code. Now, range is something that returns basically a sequence of integers starting at 0 and ending before 5.
So
0,
guys,
1,
I
2,
do
3,
think
4. It actually does something
like this. We can, if you don't understand stuff, you can search for on YouTube. That will help you. There's a lot of people. I did see it before actually. There's a lot of people having explaining it very, very good. Let's continue.
a little different we're going to talk about later in the course, but think of it for now as giving us the collection of integers 0 up through 4. And so if I go over here and type it, I say for n in range of 0 to 5, print out n, I get the same behavior. But this code's easier to see. It says for n in this sequence, do something. As we said, range gives us back, in essence, the integers 0 up through 4. We'll see some other variations on range shortly in terms of other ways in which we control it. But the for loop gives us a nice way to capture easily an iteration, a repeating of code some number of times, based on, in this case, a specific number, although I could also base it on a test. There's, just to recapture this then, the overall general format for a for. The special character in this case using range to give me out a set of numbers and a body of code that I'm going to execute. And just to remind you again, it says each time through the loop, variable is going to take a value. The first time it starts at the smallest value in range. The next time
Please, internet.
it gets the next value, in this case for range added by 1, and so on. Now I can actually be a little more clever about range, because maybe I don't want to do every value in that range. Maybe I want to skip some of them. So in fact, I have something that says I can start at a different point than 0 if I give it 2 arguments. In this case, it'll give me the range of numbers from 7 up to but not including 10. Or I can give it 3 arguments. Start at 5, end when I get up to or past 11, but do it by 2. And in each case, I'm going to get a different range out. So let's look at what those do. If I go over here and say my sum is 0, And then I'm going to say for I in the range 7 to 10, I'm going to increment my sum
Internet.
by I.
Yeah. You're nice.
And then if I print out
my internet
sum,
is nice.
I get 7, 8, and 9 added together, which gives me out the thing I would expect to see. If I do the second one, my sum again starts out as 0, and for I in the range 5 to 11 by 2, this should give me 5, 7, 9, but not 11. And again, I'm going to say my sum, I'm going to increment by I. Remember, plus equal says add to my sum the value of I. And I print out my sum. I get 21 in this case. 5 plus 7 plus 9. Sounds right. So I can use range to actually give me a set of values. But the nice part about all of this is the for loop always will just run through all of those values, executing the body of the loop each time through. Now, as I'm doing these loops, it might be the case that I want to get out of one of them. I might want to stop if something is actually, for example, a condition is true. And for that, I have another special thing called a break. And does exactly what you...
So actually, guys, you know, I do watch a lot of programming YouTube guys, and I just see guys who do programming, so I noticed a lot of stuff. So I already noticed this in another language. I don't think it's Java or C++, I think. So I technically I know it's like breaking the loop, but I just don't know what is loop in C++, but I do know what's loop in Python. I'm tired actually, so I think I will finish this video and wrap it up.
would expect. If I'm running through some code and I execute, or see rather, that special keyword break, it stops the execution of that loop at that point, or that code block at that point, and breaks out of it. So in this case, if I'm inside this while loop and I hit break, it will never execute that expression. It will pop out of all of this and pick up at that point. That lets me control how I want to deal with loops. For example, I might see a particular condition is true, and based on that say, I don't want to do the rest of this, and jump out of it. I could write it as an if, but the break gives me a natural way to control where I am inside of that loop. And so there's an example. I could set my sum equal to 0. I could run over that range, but I'd say, in this case, if it's actually equal to 5, I can just break out. While I'm typing that in, think about what this might do. So I'm going to set my sum to 0. For I in range 5 to 11 by 2, I'm going to increment my sum by I. And then I'm going to say if my sum is equal to 5, break out. And what do you think? I look at the value of my sum, it's just 5, which is exactly what I'd expect, because the first time around I is going to have the value 5. I'm going to increment my sum by 1, but then this test is true, and this break pulls me out of that entire loop and stops the computation. Silly example, I agree, but it lets you see how break controls the actual processing. I'm breaking myself out of a loop when I decide I'm ready to do that. And there's the body of code it's going to break out of, which is why it stops after only the first stage. To put all of these together, here's a little summary of for and while loops. In a for loop, we know the number of times it's going to run through an iteration, although I can end it early with a break, because I've defined the range of things over which I'm going to do the work. It uses a counter that's captured inside the for loop itself. I can always rewrite a for loop as a while loop by taking that variable that I'm using, that counter I'm using, pulling it outside, initializing it, and explicitly doing the increment to the counter inside of the loop. A while loop can have an unbounded or unknown number of iterations. Again, I can always end it early with a break statement, But I here have to just set up the counter ahead of time outside of the loop, and I have to make sure I increment it inside the loop. And unfortunately, I can't always rewrite a while loop using a for loop. You'll see in most code, we tend to use for loops when we know what we're going to do as a computation. We'll use the while loop when there's going to be a condition that we can't predict that's going to allow us to break out of that loop. But both of them give us the first version of iterative algorithms.
So guys, I'm really tired actually. Wrapping up everything, and I think I will call it for tonight. I'm a little bit disappointed for this. I will try to find a solution by tomorrow. I'm going to do the exercises, and I'm going to sleep after that. I am tired, I have to work tomorrow. So, nice to have you here with me all the way. My channel, don't forget it. Do this algorithm things, YouTube algorithm thing, that will help me spread my journey out there. So from France, have a nice day everyone. Bye bye.